Okay, so we're gonna go ahead and show you a little bit the course. I still got some email, some people asking how to access to the course in here. So let me just have a very quick, review again. You will go to the DallasCollege.brightspace.com, or you can go to click the Dallas College homepage, go to the online tour and click on eCampus. It will take you to here. Okay, after you log in, you can click this one to see all the courses you have, or you can click this one, and select the course, whatever course you have here. I like to use this one, it's easier to see, so that way you can go to your course right here, and after you go into your course, you can just click the content. Okay, click the content, it will list everything in here. So where do you do the homework? You will need to go to the MindLab Math in here. All right, if you go to the MindLab Math, you can click the MindLab Math assignment, or you can go to the home page and then you click on assignment. Okay, so you can just go ahead, click the assignment in here. It will take you directly to the homework assignment, in here. So this one you can see is still the section. The video, since this is a lecture, so the video is optional. Okay, I leave it there just for the online course. If you want to review some of the Pearson video, it's still there. Okay, but the homework is required. Video is optional for the lecture class. All right. So you're going to do a 1.1 homework, 1.2 homework, and then you're going to have a quiz. The quiz, you have 3 tries, okay? Each try is 30 minutes. So the quiz is very short. It's only 1 or 2 or 3 questions only. So 30 minutes is enough for the quiz, all right? And then plus you got 3 tries in here. So that's how you do the homework. And if you do the homework, you also have a view and example in here. So look at that. If you do not know how to do this one, you can go to view and example, and it will take you step by step. You click continue, it will take you step by step for that. You can also get a video in here, or you can open a textbook, or if you click ask the instructor, it will send me a link. All right. But don't send every question to me, because I want you to try on your own first. Okay, so you always go to the view example and trying to do that first. 95% of the question will have a view and example. All right, only very few questions did not have a view example. All right, so that is the homework assignment. Today we're gonna finish the section 1.1, which we didn't quite finish last time. Because we got a lot of overview on the orientation. Review the x and y intercept in here. Okay, so if you want to find the x-intercept, the quick and easy way here is you let the y be 0 and then solve for x, right? So for 2x plus 3y equal to 18, you replace 0 for the y, so this is gone. So you have a 2x equal to 18 left and solve for x. So that's the x-intercept. All right. And then if you want to solve for y-intercept, you let x be 0. So x is 0, only y items left. So 3y equal to 18, y will be 6. All right. And then you can plug those 2 points into the coordinate and then graph them. Okay. So since we already talked this last time, I just have a very quick review for what is the x-intercept and what is y-intercept in here. All right. Next one, we're gonna talk. This one is called a parabola. Okay, parabola, you will have more than 2 points in order to graph this one right here. You can plug x equal to, like I say, x equal to 0, x equal to whatever that number in. So you can go to the table in here and then switch the x and y. So I can also show you how to graph this one in my calculator. Hopefully you can see the calculator as well. My desktop calculator in here. How do you input this one into calculator? Okay, so that is a lot of time people ask at the beginning. You go to y equal to, all right? So when you hit y equal to, we have an x squared minus 9x minus 12. So x, and then that's the square, okay, minus 9x minus 12, all right? And then you hit enter, and then you hit graph right here. So that we're giving you the graph. If you cannot see the entire graph, you can go to zoom, okay? And then I like to go to one called the zoom fit, okay? Zoom fit, you cannot fit the entire window. And a little bit, cut on the right side. So you can go to the window, adjust a little bit. Maybe I want to maximize for the X with, like I said, 25 instead of 10, okay? And now we're giving you the entire pretty graph for this parabola, all right? And then if you go to second graph, you can see the entire table, okay? You can see the entire table in here for the x value corresponding to the y value, all right? So looks like this one, we have a 2x-intercept in here. You can see the graph passing the x-axis twice. So you have a 2x-intercept, and then you have a 1 y-intercept here, okay? 1 y-intercept. So the way you find the x and y intercept is the same as linear. Look at that. If you want to find the y intercept, you let x be 0. So when x is 0, y is negative 12. So if you look at this graph, this one is negative 12 in here, okay? And then if you let the y be 0, let's see, I don't have a y equal to 0 in here because it looks like this x-intercept is a decimal point, okay? It's not an integer. You have a little bit decimal point right here, a little bit negative 1 point something in here, all right? So we will talk how to find the x-intercept for the parabola in chapter 3, okay? So, but this is the x-intercept right here. You make y equal to 0, all right? So that is the parabola. You can graph by hand, but it's very tedious to graph by hand because you have to have a, at least 5 points in order to graph this one by hand, all right? So for the parabola or the cubit, I recommend to use the calculator in here, okay? Now next one we want to talk is a distance formula. So the distance is a straight line between 2 points. So if I have a point A to point B right here, okay, so let's see if I have a point A. All right, so if I have a point A right here, okay, and then this is a point B, and I want to look at the distance between A and B, so how do I do that? Well, you can set up this one is like a triangle in here, okay? Looks like a triangle. So we do the point A and point B here. Point A coordinate is x1, y1. Point B coordinate is x2, y2. All right, so if you look at this one right here, if I draw for this perpendicular line to the x and y axis, this looks like a triangle, right? So remember the Pythagorean theorem, the triangle, you have a a squared plus b squared equal to c squared, okay? You have a squared. Okay, I'm trying to get my calculator, my writing tool at work. Okay, so you have a Pythagorean theorem is a squared plus b squared equal to c squared, okay? And then if you want to solve for c, you just take the square root on both sides, right? So this is c is the hypotenuse in here, and then this two leg is x1, x2 minus x1, and then this leg is y2 minus y1. So that's the side, right? So you have this a squared plus b squared equal to c squared. And then if you want to solve for c, you just take the square root. Take the square root on both sides. Okay? You take the square root on both sides in here. So that is c in here. This c here is the d. Is the distance d in here. All right? So that is how this formula comes from. Okay? All right, so if I have 2 points right here, right? This one is 2 points. I want to find the distance between -2, 2, and 3 to -6. All right, so basically you just plug it into the formula. But I like to look at this one. I like to mark this x1, y1. Okay, so I will mark this one is x1. This one is y1. And then this is x2 in here. Okay. All right, and then this is y2 in here. All right, so your x1 is -2, your y1 is 2. The reason you mark x1, y1, x2, y2 here is much easier, so you can match to the formula, okay? So x2 minus x1, which is -2, and then square, right? And then plus y2 minus y1 square. And then you just go to calculate, okay? And then calculate, this is the square root of 89. Square root of 89, if you simplify into the decimal point, is about 9.4, right? So if you can use calculator, square root of 89, you can use the, let's see, you can use the calculator. All right, so how do you second x squared is the square root, okay? Square root 89, and then you hit enter. So if you don't do 1 decimal point, this is about 9.4. All right, so that is how you find this distance in here. Okay, any questions? I want to see if any question. If you have a question, you can jump in and unmute yourself and talk. Okay, ask question if you have.
So what would the formula for the distance be? It'd be x1 minus y1, and then, okay, there it is.
Right here, x2 minus x1 square plus y2 minus y1 square. It doesn't matter which one you mark as x1. If you want to make b as x1, y1, that's totally fine. Okay? So x1 or y1 is really up to you. If you want to make a -2 and 2 as x2, y2, that's fine. But you always have x and y as a pair. All right, and this is the formula. The good news is this formula is on the formula sheet for the test. All right, so it does have a formula sheet for you on the test, but you need to know how to apply it on that. When you do the homework, you can make your own note, right? You can make your own note for the distance formula. All right, next one is called a beam point formula. Beam point is middle of the point, okay? So don't confuse the beam point and the distance formula. Beam point is trying to find a xy coordinate for that point. All right, so the beam point, we're going to call this one is M, the beam point in here, okay? And then if I have this one is P and Q, okay? P and Q. P coordinate is x1, y1. Q coordinate is x2, y2. And I want to find my beam point M coordinate. So my beam point M coordinate, my x for the beam point will be average for the x1 plus x2 over 2. And then my beam point for the y, for the M, is using y1 plus y2 over 2. So you just average the x, average the y for the beam point, okay? So remember the beam point is using addition. If you want to find the distance here, this distance formula inside is the minus, right? Inside is minus. And then you have to square them first before you take the square root, okay? All right, so beam point is much easier. You just add a x1 plus x2 over 2 for the x. Add a y1 plus y2 over 2 for the y, okay? So for example, if I want to find a beam point of these two, what do? I add this is x1, this is x2, so you add the x together and then divide by 2 for the x value, okay? And then you add a y, so this is your x1 plus your x2, which is 2 divided by 2. And then this is y2 plus y1 plus y2 divided by 2 for the y. So you have this beam point x is -1, right? You simplify that. So your beam point for these 2 points, x is -1, y is 3/2. Okay. All right, so sometimes people will ask why we need to find a distance formula, why we need to find a beam point. Because if you look at this one right here, right, this is -2, -4, and -2, which is in Q3, third quadrant, okay? And then this one, both x and y are positive, so it's in the fourth quadrant. So this Q1, Q2, Q3, and Q4 right here, all right? If you look at this one, you average the x in here, average of x is -1. And then average for the y is 3/2. So this beam point is in second quadrant, in here, second quadrant. All right. Any questions? Okay. So we look at the beam point, we look at the distance formula. A very important one is this one can use it to find a circle. Okay. So a circle is a set of all points in a plane that has they have a fixed point, a fixed distance from the center. Okay. So the distance from the center, we call this one is radius. Radius using r, right? And then the center, we usually using h and k for the coordinate x and y. So the equation of the circle with the center h and k and the radius r is using this one. This is called the standard format for the circle. X minus h squared plus y minus k squared equal to r squared. So this one is good to remember for the circle standard equation. All right, so how do I find the equation for the circle that having a radius is 5 and the center at 3 and -7? All right, so you can make a draft. If you want, you can make a draft in here. 3 and -7 is in the fourth quadrant, right? Fourth. 3, okay, 3 and -7, so maybe somewhere right here. All right, so that's your center. 3 and -7, and then with radius as 5, so this probably look something like that. Okay, not quite circle, but you got an idea. All right, so this radius is 5. Okay, radius is 5. And then the center here is 3 and -7. 3 and -7. That is your center. All right, and we want to find out this equation. Okay, so the equation, remember the equation for this one is x minus h squared. Okay, that's a standard equation for the circle, plus y minus k squared. Okay, and then equal to r squared. All right, so my r here, this is my r, right? My r here is 5, so that will be 5 squared. And then this will be x minus 3. All right, so what is my equation here? This will be x, h is 3, so this is x minus 3 squared. Okay, plus y minus k. K is -7, so minus -7 will be plus 7. All right, and then square. And then equal to r squared. R is 5, so 5 squared is 25. All right, I can leave it as it is because this is a standard formula for the circle. All right, so that is my circle formula. So you can see, like in this case, you know, we have the circle in here. Okay, any questions? Sometimes
would we need to solve for x or y?
Say it again.
Would we need to solve for x or y?
No, you leave it as a standard format. Leave it as this format right here. So if you just need to square the r, all right, you don't have to get rid of this perfect square. we keep the perfect square for the circle, because this is called a standard format in here. All right, good question. Any other questions? Okay, so if not, that is our fourth section. We just completed today. So now you can finish the section 1.1 homework. Okay, I can go to look at one of the question in here. Let's see. Okay, so look at this one right here. You want to find the equation or the circle that having this graph. All right, so how do you know this one right here? How do you write down the equation for this circle? Well, you're gonna need to find your own what? Center and find your own radius, right? After you find the center and the radius, you can just plug it into the formula. So where is the center in here? You can see this one, the center must be in second quadrant. So second quadrant, x is positive, y is x is negative, y is positive, right? So you can go to look at this one, the center, maybe somewhere. This point looks like the center to me, right? You can see this point is in the center. And then you go to find the x, how many, the center in here. This one will be 1, 2, 3, 4. Okay, so x will be negative 4 in here. And then go to the y. Y will be all the way from here, right? So y here will be 1, 2, 3. Okay, so this is y axis 1, 2, 3. So in here, this center looks like a x or h is negative 4, k will be positive 3. All right, so you have h and k, you need a r. Okay, how much is the radius r? R is from center to the end of, to any point, right? Any distance. So you look at the vertical or you look at the horizontal. If you look at the horizontal, this one is 1, 2, 3, 4. Okay, if you look at the vertical, 1, 2, 3, 4 is the same. All right, so this is the center in here. So your radius here is 4. All right. So after you have a h and k and a r, you can write down the equation and using the standard format. So you're gonna have a x minus h, which is negative 4. You're gonna have a plus 4 square plus y minus 3 square equal to 4 square, which is 16. All right. So that is your equation in here. Okay. So this one is just reading the graph, and then you can do that on, you can write down the equation on your own. If you do not know, you can still view an example right here, right? This is the standard format, so you will need to go to find the h and k. This one, h is negative 2, k is 3, and then find the r. R here is 6, so you write down in a standard format. All right, so this is your final answer for the circle. Okay, so of course this graph, the number is a little bit different than your homework, so you need to come back to do your own graph. All right, you cannot copy the answer from the example that way. So you do your own graph in here and then write down the equation. All right, so that is how you do this type of homework. Okay, any other questions? All right, if not, we're gonna go to look at the second section for the chapter, which is a little bit more graph and function. Okay, so the section here, this fourth chapter is pretty much talking about a function and a graph. All right, we want to know a graph is a function or not. Okay, and then we also introduce a very important concept. It's called domain and range. Okay, all right, so what is a function? Well, for a function is called a correspondence between a first set is called domain, and the second set is called a range. So if one domain corresponds to exactly one member of the range, that is called a function. So basically it's 1x, the domain is the x, the range usually is the y. Okay, so we say if you have a 1x corresponding to only one y, that is a function. All right, So look at this one right here. This relationship actually is a function. Sometimes people say, well, I have a negative 6 equal to corresponding to 36. Positive 6 is also corresponding to 36. But this is 1x, only have one output y. Even they have the same y, but this is still qualified as a function. Okay, it's still qualified as a function because they only have exactly one y. All right. The first set of the x value we usually call it is a domain. The second set of y value we usually call is a range. Okay, so sometimes in math we like to using the f notation. Okay, so f of x is equal to is the same thing as y, right? So but using the f of x is much easier to do it and write in math. Okay, so for example, if I giving you f of x equal to 2x squared minus x plus 3, how do I find f of 0? And what does f of 0 mean? So that is the method or algebra expression, right? The f of the 0 is trying to find a y value when x equal to 0. Okay, so this is a math language in here. All right, so we call f of the 0. So if I using this symbol f function, so I don't have to write down the entire sentence, say, please find a y value when x equal to 0. Right? So I just need to write down f of the 0 and you should know what to do. Okay? So we plug x equal to 0 into the equation and then y will be just equal to 3. Okay? All right, so you replace x by 0 and then this will be all 0, right? Only 3 there. So this point, corresponding point will be 0 and 3. So x is 0, y is 3. So that is your y-intercept, basically. All right. Similar to f of negative 7, so you want to find a y value when x equal to negative 7. So you replace x by negative 7 in. Remember, this is x squared, so negative 7, the entire negative 7 need to be squared. All right. So you have a 2 times this negative has a square because x is negative 7. So when the negative 7 square will become positive 49. All right. And then this is minus x minus negative 7. So you become positive 7 in here. And then you add 3. So that's the final answer. Okay, 108 for f of negative 7. So this means when x equal to negative 7, y value is 108. All right. And you also have this kind of thing. X is an expression, not a particular number. So when x equal to 5a, how much is the y value? Well, we can replace x equal to 5a in. Okay, so replace x. This one don't have an answer. All right, let's do this together. Replace x equal to 5a. All right, so what do I do in here? We will replace x equal to 5a in here. So we're gonna have this equal to 2 times 5a squared okay, 2 times 5a squared minus 5a. Okay, and then plus 3. All right, so that's how you do that. But we have to simplify. We have to calculate this one right here. 5a squared, 5 also need to be squared. So 5a squared is 25a squared. A 25a squared times 2 will be 50. 50a squared. All right, so this one will be 50a squared minus 5a because there's not a like term, so you cannot add them together. And then plus 3. All right, that is your final answer. So your final answer is also an expression. Okay, so that means when x is equal to 5a, your y will be equal to 50a squared minus 5a plus 3. Okay, so that is the answer for that. Okay, any questions? All right, so graph of the function, we need to know how to graph the different function. The graph for the function is very, very important, okay? If you continue to math, to calculus, you can see every graph we learn in college algebra gonna be using in calculus, okay? So graph of the function is very, very important, all right? Not only you know how to put it in a calculator, I also want you to be able to kind of memorize a little bit some of these functions we have. Like this is x squared minus 5, right? So how does this one look like? If I don't use a calculator, I should be able to sketch this one, okay? As I said earlier, this x squared coefficient, this actually is positive one. So positive is a smiley face, right? A happy face, so it's facing up, all right, facing up in here. And then this is similar to x squared, but moving down for 5 units, all right? So this one, just, if you have a y equal to x squared, this is how you look at that, right? And then it's just moving down for 5 units. So look at it, this is moving down for 5 units, all right? So you have a y-intercept right here. This is y-intercept, x is 0, right? So when x is 0, this is gone. So only negative 5 there. So that's the 0, negative 5. So that is your y-intercept. And of course, you can find the x-intercept as well, right? You can find the x-intercept, let y equal to 0. So if I let y equal to 0, I can go to solve for x, right? So this will be x squared minus 5 will equal to 0. And then how to solve this one, we will have that in chapter 3. All right, you add a 5 on both sides, so you have x squared equal to 5, and you take the square root on both sides, right? Take the square root on both sides. Make sure you take the square root on both sides. You have a plus minus always, okay? So you're gonna have a plus minus square root of 5. Square root of 5 is 2 point something, right? It's 2 point something. So you have a positive minus 2 point something right here. So this is I will just estimate like about 2.2, okay? So something like that, maybe 2.1 something. Now I'll just say, estimate about 2.2. So you have an x-intercept here is about 2.2, and then this one is negative 2.2, and y is 0. Okay, you can also put this one in a calculator. As I mentioned earlier, we allow you to use a calculator for this course. So I am going to y equal to, and then if I graph this y equal to x squared, okay, I just want you to compare a little bit. I'm gonna zoom to standard this time, so I can zoom number 6. All right. Okay, so that is y equal to x squared, and then I am going to do y equal to x squared minus 5. Minus 5. Okay, so you can tell this one is the same graph, but moving down for 5 units, the red one, compared to the blue one. Okay, so this one is moving down for 5 units in here. All right, so that is how you do the graphing in the calculator. Or if you do it by hand, you're gonna have a several x and y value in here, right? So you randomly choose your x value. You usually choose some positive, some negative value, and x equal to 0, and then you calculate the y. So you have an ordered pair of x and y, and then you put it in a coordinate, and then you connect them together. All right, so that is how you graph this one in here. I usually only recommend you to do the graphing by hand for the linear, okay? For the parabola, the cubit, all those things, you just understand the sketch, okay? But for the detailed graph, you can put it in a calculator. But I want you to understand like at least how does that look like, okay? All right, this one is a qubit function. You can see this one, the highest power x is 3, so that is called qubit function, okay? And then if you want to graph the qubit function, of course, you need to more than have 2 points, all right? But this qubit is stretching from Q1, this is Q1 to Q3, okay? Whatever the middle path is, but this is starting and ending at Q1 and Q3. All right, with this coefficient is positive, the highest power coefficient is positive. All right, you can put this one in a calculator as well, okay? Sometimes people say, how do I graph a qubit in a calculator? All right, so let's see, you have x, and then this is the power button, right? When you put this one, it will go to the power, so that's 3 power. But make sure you move it down, you cursor it down before you put a second item in here. So I have the x cubed minus x, and then hit graph. So that is how the graph look like, right? And then you can go to second graph, you can look at the table, you can look at the table here. Look at that, when x is -1, y is 0. When x is 0, y is also 0. When x is 1, y is also 0. So that means you have a 1, 2, 3, 3 x-intercept in here. 1, 2, 3, 3 x-intercept. Okay? Alright, so that is the cubic function. Any questions so far? All right, the next one here is called a square root. Okay, this is the square root graph. So we have this entire graph in here. As you can tell, this square root now x has a limited value, right? X doesn't go down anymore. The x value is only start with -4, and we're gonna talk why is this later. All right, that is called a domain. Domain of the x value, it doesn't go, this one doesn't graph all real number for the x, okay? Only graph x starting from -4 because because this is a square root. Square root is an even root. Even root, everything under the root has to be greater than or equal to 0. All right. So if you go to solve for x in here, -4 on both sides, x should be greater than or equal to -4. So that is called a domain for the x value. So that means the value of x can show on the graph. Okay, it doesn't go down in here. I can also put this one in a calculator. Okay. All right. So where's the square root? You will need to have a second x squared will be the square root. Anytime you want to exit the blue symbol, you need a second in here. All right. So just FYI, look at this one right here. If I have a 8, if I just hit 8, this button I got 8, right? If I hit second 8, I got this blue one is V. Okay, if I hit the green one, I will get a P. So green one will be alpha 8. Alpha 8, I got a P right here. So look at this button. Each button has three types, right? This one is 9, and then if I hit second 9, will be getting the W, right? And then if I hit alpha 9, I will getting the Q in here. Okay, so just FYI. So I want the square root, so I will need to have a second x squared. So that's the square root of x plus 4. Okay, and I hit enter and I hit graph. So you can tell, like when this one x only start from -4, right? And then I can go to look at the table. What happened when x is less than -4, like a -5? Oh, this is gonna all show you the arrow, right? So what does the arrow mean? That means there's no real value for the y. Okay, so when x equal to -5, there's no real value for the y. So that is called a domain. So when we talk a domain, we all talk the real value, real number in y. So when x equal to -4, y has a real value, real number is 0. When x less than -4, which is -5, y doesn't have a real number in here. So that is the domain about. So domain is talking about, the x value can still produce the real number in y. Okay, and the real number in y, you can see that in the graph. All right, so that is how this graph will look like. Okay, vertical line test. It is possible for a vertical line to cross a graph more than once. Now, if this is the case, this graph is not a function. Okay, so vertical line test is only one x value corresponding to only one y. If this is the case, if you only have one x corresponding to one y, this one is called a function. A function. Okay, if we have a more than one y, it's not a function. All right, so you can tell this one, if I draw a vertical line right here anywhere, this is only cross one point, right? So this one is a function, the graph. B is not a function because you can tell this is passing more than one point. Even C is not a function either because this is passing more than one point. Okay, all right, so that is called a vertical line test for a function. All right, so you can see this one circle actually is not a function because it passes 2 points. If drop a vertical line, it's passing 2 points. Okay, this one looks so curly and everywhere, but this one is still a function because if you drop a vertical line, it only passes 1 point. Number F is a little bit tricky because if you drop a vertical line, what does this mean? Well, this one, that means passing this solid point. Solid point, that means included. All right. How about an open circle? Open circle, that means it's not included. So actually, this one can still consider as a function because if I draw a vertical line, it only includes this point, doesn't include an open circle. All right. So this is still a function. Okay. So that is how we can visualize a graph is a function or not by using the vertical line test.
Is all of this going to be on section 1.1?
This is 1.2 already.
Oh, okay.
Yeah, 1.2 for this one. 1.1 end up with end at a circle net point. So 1.2 is continue on the 1.1. It's more graph and function. So this one is 1.2, okay? All right, so how do we find a domain for the function? We can actually see the domain from the graph, okay? But sometimes, it's hard to estimate from graph, so we need to be able to find a domain in algebra, solve the domain, basically, okay? So the domain, that means what kind of x value is able to produce the real value in y. All right. So sometimes I kind of think a function is kind of like a machine. Okay. And the machine, you need an ingredient. You have an input, you have an output, right? So your input is x value, your output is y value. And you cannot put the junk to the function, to a machine, because it will damage the machine, that kind of thing. All right. So that is, so different function has a different input. Like I said, if you're driving a car, right? The car, you need a regular gas or you have a premium gas, but the regular car, you cannot put a diesel in there because it will damage the engine, that kind of thing. So a function is kind of like a machine and your x value is kind of like the input. What kind of input you can have for that function, for that machine. All right. Okay, so basically when we consider the domain, we need to have two different type. One is the denominator. We all know in math for a long time, denominator cannot be 0, right? If your denominator is 0, it's called undefined, all right? Even a calculator cannot handle that. So this one is x value. X is, we have to define the x value in order for this function, to function well, basically. All right. So that means x, sometimes people say, oh, x cannot be 0. No, it's the entire denominator cannot be 0. In this case, x actually can be 0. All right. It's the entire denominator cannot be 0. Okay. So the entire, if you look at the f of the 1, how much is the f of the 1? Well, if you replace the x by 1 in here, y will be negative 1/2. So that is a good one, right? If you replace the x by 3 in, what happened? Well, look at that. 3 minus 3 is going to be 0. So this one is called undefined. And y doesn't exist. We usually call DNE. Does not exist, right? So that means x cannot be 3 because it makes y undefined. All right. So how do I find a domain in here? My domain in here for the x will be, this is usually how we write down a domain in here. X minus 3 cannot be equal to 0. All right, and then I make it to 0, solve for x. So x will be 3. And then I just get rid of that point. So the domain for this one is x cannot be equal to 3. That is your domain. Okay, questions? All right, some of the denominator will be a little bit more complicated, but the concept is still the same. How do we find a domain for this function h of x equal to this whole thing? All right, so the concept here is x, so my entire denominator cannot be 0, right? So x squared plus 2x minus 3, this whole thing cannot be equal to 0. All right, so we usually make it to 0, solve for x first, and then get rid of them, get rid of this x value. So how do I solve this one? If I make it to 0, right? So if I make it to 0, like I say, if I make it this whole thing to 0, and then how do I solve this equation? Well, we can do the factoring very quick. So now you can see factoring is so important. All right, so we factor x squared into x and x, okay? And then we factor negative 3, you can factor into 1 and 3, 1 and 3, okay? Which one need to be positive, which one need to be negative? So this inner multiply will be positive 1x, right? And then this outer multiply will be 3x, all right? These two add up together, these two add up together, need to be equal to 2x, positive 2x. So this one need to be positive, this one need to be negative. So now I know this should be negative, this should be positive, okay? All right, so that's for your factoring. Okay, I factor the first term, I factor the last term, and my inner and the outer multiply add up together should be equal to the middle term. So that's a FOIL, right? And then you go to solve this factor. So we have a x minus 1. If you have a 2 factor, multiply each factor can be 0. So x minus 1 will be 0, x plus 3 will be 0, and then we solve for x in here. Okay, you add an x on both sides, so x will be 1. You add x, you minus 3 on both sides, x will be negative 3. All right, so what does that mean? That means when x is equal to 1, the denominator will be 0. So we're going to say x cannot be equal to 1, right? When x is equal to negative 3, denominator will be 0. So we say x cannot be equal to negative 3. All right, so that is your domain in here. Okay, your domain here, that means x cannot be equal to 1, x cannot be equal to negative 3. Okay, so we know if you have a fraction, if you have an x in the denominator, is the entire denominator cannot be 0. So that's domain rule number 1. Okay, domain rule number 1 is you have a, this is domain rule number 1. Domain rule number 2, okay, when you have this square root, what is the square root? Square root is called even root, even. Okay, even root. When you have an even root, the everything under the root called the radicand has to be greater than or equal to 0. Okay, so x plus 4 has to be greater than or equal to 0. Okay, so because the even root, the R root, x can be anything. Okay, because look at that, negative 2. If you have a q is negative a. So that means if I have a negative a q loop, if I have a negative a q loop, it's still value. It will be equal to negative 2. All right. But if you have a square root of negative a, what happened? This is not a real number. This is an imaginary number. All right. So that's why even root is very different. Okay. Even root, the radicand, everything under the root has to be greater than or equal to 0. And then you go to solve for x in here, x will be greater than or equal to negative 4, right? So that is how the graph look at that. And then sometimes in the homework, it asks you interval notation. So how do you write down this one in an interval notation? Well, we know this is go all the way to the right, okay? So since it has an equal sign, so I'm gonna using a bracket. So bracket -4, and what is the large value? Large value is go all the way to infinity. Infinity always using parentheses. Okay, so that is your interval notation in here. Any questions? All right, we can also look at the domain and range in here. What is a domain? Domain is the x value. Look at it. So my domain here is this domain is -4 to infinity. And what is the range? Range is for the y value. So what is the y value in here for this graph? Can anyone tell me what is the range for the y? Okay. When x equal to -4, how much is y? Anyone? What is the y value?
0.
0, that's exactly right. Okay, so the range y here is from 0 to what? Infinity.
Okay.
Yeah. All right, good. So the range y, the minimum value for the y here is 0. Okay, this graph cannot go down anymore. All right, so you can see the domain and range from the graph basically. All right, so look at this one right here. Can you estimate the domain and range for this highest power is 4? It's called quartic function. It's quartic, not a quadratic, but quartic, Q-U-A-R-T-I-C, okay, quartic function. All right, so this one is kind of look like that. So what is the x value in here? Can you kind of tell the x value? Oh, we don't have an x under the square root, the even root. We don't have an x in the denominator. So that means domain x can be anything, all real number, right? The only thing x has a limitation is when you see x in a square root, or called even root, or when you have something x in a denominator. That kind of situation, x will have a limitation. Other than that, x can be anything. All right. But the range y, look at that, since this graph is facing up, so we do have a minimum value for the y right here, right? So it looks like this is a minimum value for the y. So minimum value for the y here is about -4. You can read from this graph -1, 2, 3, and -4. All right. And this is facing up, so y will be from -4 to infinity. All right. So that is your domain and range. And this is section 1.2 already, right? Any questions? All right, if not, we have a little bit time left. We're gonna go through 1.3. As you can see, we pick up the speed from now on. All right, 1.3 is a little bit about the linear function, slope, and application. We skip the 1.4 and 1.6. So the chapter 1, we only have a 1.1 to 1.3 and 1.5. Okay, 1.5 we will have a next week. But this week you will have a 3 section already. Okay, and that's also the homework will be due for these 3 sections. All right, so 1.3 is about the linear function, slope, and the application. So linear function, we can have a linear function called a slope-intercept format, right? You're using y equal to mx plus b. That is a slope-intercept. So that's the m here is called the slope. B here is called the y-intercept. Okay. And then if you have a slope m equal to 0, now you have a f of x equal to b. So this is a constant function, right? Constant function. And then if you have a m equal to 1, b equal to 0, so you have a y equal to x. So y and x is always equal. So this one is called the identity function. All right, identity function in here. So you can see this one right here, slope, this graph is going up, so slope is gonna be positive, right? And then same thing, this one is going up, so slope is positive. So this actually is called identity function, y equal to x. M is 1, right? M slope is equal to 1. So look at the x and y always equal. So that's the identity function, okay? And then this one is called a constant function. The constant here because look at the y, regardless of the x value, y is always equal to -2. So this is a constant, that's a horizontal line. The constant function is still a function because it does pass the vertical line test, okay? Now we have a vertical line, so if I want to graph x equal to 4, right, this is a vertical line. X equal to 4, x equal to 4, y can be anything. So that is called a vertical line. Vertical line is not a function, y is not a function. Because if you drop a vertical line in here, you're gonna pass an infinite number of the points, right? So that is more than 1 point in here, okay? So vertical line is not a function, horizontal line is a function. Because you drop a vertical line, this is only passing 1 point. All right, so that's the horizontal line. This one, y will be equal to -2, right? This one is also a vertical line, x is equal to -2. All right, so that is how you graph in here. A lot of time we have to find a slope for the linear equation. So what is the slope? If you remember from high school math, the slope m here is called rise over range, right? Rise over range. The rise is the change in y, the range is the change in x. So you using the y2 minus y1, right? And then divided by x2 minus x1. Or you can have a y1 in the front, that's okay. But if you have a y1 in front, make sure you also have a x1 in the front, all right? So we usually just like to using the first one, using y2 minus y1 seems a little bit more straightforward over x2 minus x1, right? And you can choose any point as x1, y1 or x2, y2, okay? All right, so if I have this function, can you determine the graph, the slope? Of course, we know this is mx plus b formation, so your slope is -2/3, right? And then your y-intercept here is x is 0, y will be 1. Okay, so you can do a little bit of this one right here. You can have a x is 0, y is -1, so y is +1. So if x is 0, y is +1. This is the point right here, right? So that is your point P. Okay, so that is your point. That's your point P. That's your intercept in here. That's your point P intercept. Okay, and then since this slope m here is -2/3, so you can use this one to graph. So you have a x. If you have an x going to the right for 2 units, 1, 2. Okay, y gonna be going down for 3. All right, so this is 1, 2, and then 1, 2, 3. You can pick any point in here. Okay, you can pick any point. So x increase 2, 1, 2. Y gonna be moving down. Okay, so this one right here, this is kind of emphasized in here. Okay, or sometimes you can just using 2 points. X is 0, y will be 1, right? And how about when x equal to 3? Okay, when x equal to 3, y will be -1. Look at it. When x equal to 3, so 1, 2, 3. All right, y will be -1. So right here, so that's 3 and -1 right here. Okay. All right, so this is giving a little bit type of the slope. So when you have a positive slope, the line is from left to right is going up. Okay, that is the slope. If you have a negative slope, it's lines down from left to right. All right, so this is passing 1 and 3. This is passing 2 and 4. All right, if you do not know, you can put in the calculator to graph them, right? And then we also know the horizontal line y did not change, so y did not change, so the change of y will be 0, so slope will be 0. All right, so this is kind of cross-country skiing, right? Very easy. You can slope is 0. Okay, vertical line, x did not change, y changed, but x did not change. So you're gonna have a 0 in the denominator, and we said that 0 in the denominator is a no. So that is undefined slope. Okay, undefined slope. So I usually tell people, say you cannot ski vertically, right? You're gonna be a free fall. So that is this one right here. All right, we also have another question here called average rate of change. Okay, so slope can also consider as average rate of change, and this one you can use it in a lot of application. Okay, when you have two lines are parallel, what happens? Slope will be equal. Okay, look at that. The two lines are parallel. That means they never intersect each other. So M1 and M2, M1 and M2 are the same. Okay, so when two lines are parallel, slope is equal. All right, and there's another relationship called two lines are perpendicular. So what happens if your two lines are perpendicular? Your M1 times M2 gonna be equal to -1. Okay, so that is this one. If two lines are parallel, we know the relationship of this slope. M1, the product will equal to -1. But if two lines are parallel, that means their slope are equal. Okay, so those two things are also pretty important in algebra. Okay, so can you find a slope and a y-intercept for this equation? Of course, this is a slope, right? Slope is negative 0.25, and the y-intercept x is 0, so y will be negative 3.8. Okay, so that is your y-intercept in here. All right, that is your m. So this is in a slope-intercept format. All right, so if you don't have it in a slope-intercept format, what do? Well, you have to solve for y. Okay, so that is the one we talk even in the first class, right? So you need to know how to solve for y, and write down y equal to mx plus b, and now you will have a slope and that in here. Okay, so how do I solve for y in here? This one, everything is on the right, so I am going to just move my y to the right side. Okay, so I'm going to plus 6y. I'm going to plus 6y on both sides. Okay, so if I plus 6y on both sides, this will be 3x minus 7 equal to 6y. So look at that. You don't have to make a y on the left. You can make y on the right as well. And then I'm going to divide both sides by 6. Okay, so 6 and 6 cancel out. So I have a y equal to, okay, I have a y on the right side, and y equal to 3x over 6 will be 1/2 x. Okay, minus 7 over 6. All right, now I have this one in the mx plus b format. So my slope m here will be what? My slope m here will be 1/2. My intercept here, x will be 0. My y will be -7 over 6. So that's my y-intercept. Okay, so you can put this one in here and then solve that quickly that way. All right, and looks like that is the end of the section 3 already. Any questions? All right, if you don't have any question, we have a little bit of time left. We can go to look at a couple homework questions. Okay, so let's go ahead and look at some of the homework questions. Let's see what we have in here. All right, so let's see if I go to the assignment. All right, let me go to build a student's home. That way we will see entire course today. All right, so we're gonna go to the homework section 1.3. All right, let's pick number 10. Okay, let's pick question number 10 to see what we have.
Where would the formula sheet be on these?
Formula sheet, let's see, formula sheet, you should have one in the, let me see, in here, start here. Okay, if you go to the text review here, right? If you go to the text review here, you have this formula sheet. So that this is the page usually you will be able to use in the test. Okay, so now you can see what kind of formula in here, what formula is not here. So the formula here is you have a quadratic equation formula in here, and then this is a distance formula, right? This is a mean point formula. This is the standard for the circle formula in here, and then you have a y equal to mx plus b slope intercept formula. You have a y2 or y minus y1 equal to m times x minus x1. This one is the, if you divide by both sides by this one, you have this slope formula basically. All right, you have a slope formula, and then you have this one is for chapter 3 vertex formula in here. Okay, so you do have all this formula in here. It is you're gonna use right away. All right, anything that is not in here you need to remember, okay, because this is the page formula you can use for the chapter 1 test, chapter 2 test, and the final test, that kind of thing. All right, good questions. Any other questions? All right, let's just look at one of the question we have. Let's see. Oh. All right, so that one was ended. Okay, so number 10 here, find the slope and the y-intercept for this equation, okay? So we have a y equal to negative 15. How much is the slope? We don't have a mx plus b, so what's the slope here?
Nothing, just 0?
0? 0. 0 is the slope. Sometimes it's undefined, but this one, y equal to negative 15 is defined, right? So slope is 0. You can check your answer. All right. And then how much is the y-intercept here? Type it in the order pair. So what does that mean? You always have to look at the format here, right? It said type it in the order pair. So order pair, that means you need a what? Parenthesis. And then how do you type the order pair in here?
It would be 0
X
and
then
15,
Y.
right?
Yes.
Negative 15.
0
Negative 15.
and what?
Negative 15.
Negative 15. All right, okay, good. And then you can check your answer. All right, and then you check your answer is correct. You go to the next question, you know, things like that. All right, so the next question here is you're gonna graph the slope and the y-intercept. So basically, you just need to choose the correct answer, right? So you can go to enlarge that. If you cannot see that clearly, you can enlarge really big, and then check this one. So which one is the correct answer? I know if you want to put this one in the calculator, you have to solve for y. Okay, or if you want to graph on your own, so there's several ways to do this one. You can put in a calculator to graph, but you have to solve for y in order to use the calculator. Or you can find your x-intercept and y-intercept graph on your own, okay, and then match the graph here. So there's several ways to do. All right, so if I graph on my own, let's see how do I graph on my own. Okay, so I have my 2x minus 4y equal to 12. Okay, so do you realize this is all like an even number? So I can divide both sides by 2. Look at it. I'm going to simplify this equation. Okay, I can divide both sides by 2 first. And that way 2x divided by 2, I got an x, right? And then 4 divided by 2, I got 2y. Okay, so this look a little bit easier. And then 12 divided by 2, I got 6. Okay, so that is the equivalent equation to the previous one. And I can do a little bit of x and y coordinate. Okay, I can do a little bit x and if I let x equal to 0, what happens with the y? X is 0. So we're gonna find a y-intercept that x equal to 0. Divide by both sides by -2, so y will be what? -3. Yeah, -3. And then if I let y equal to 0, okay, y equal to 0, x, this y equal to 0, y will be gone. So x will be what? 6. All right, so I can graph on my own. Look at this one right here. I can graph this one on my own. X is 0, y is -3, so it should be right here. Okay, and then when y is 0, x is 6, so it should be right here. So this graph should look at something like that. Okay, not quite exact, but you know, it crosses. So this graph should look at something like that, right? So now you can go to compare the graph. So apparently A is incorrect. All right, and so A is incorrect. So B is B, C, and then how do my graph look at that? All right, so let's see how my graph look at that in here. So my graph is below the origin in here. So even this one, so I would say, you know, A and D both are incorrect, right? So the only possible answer would be what? B or what? B or C, is that right? Yeah.
I think it's B.
Okay, why is B? All right, you can check
because it shows that the
all right, yeah.
Because it shows that the x, that's where the x and y intersect.
Right. So look at this one right here. This unit here is 10. Is that right? So the unit here is 10. That means it's grid. You have a 1, 2, 3, 4, 5 in here. So you have a 5 group for 10. So each group represents 2. Is that right? So this will be 2, 4, 6. So I have a 6 in here, 6, 0. That looks right. This group is also 2. But this one looks like only 3. So yeah, B is the correct answer. Okay. And then this one, the vertical one, you can y is 0 and y-intercept will be 0 and -3. So this is -2, -3. So yes, B will be the correct answer. Okay. So that is how you do this kind of graph. So you can graph by hand, but if you want to put this one in a calculator, what happens? If you put this one in a calculator, you have to solve for y, right? So I have, so how do I solve for y here? Okay, so I have x minus 2y equal to 6, right? So I am going to minus x on both sides. Okay, I'm going to minus x on both sides. So that way I will have so this cancel out. So I have a -2y will equal to -x plus 6. Okay, and then I'm going to divide by both sides by -2. Divide by both sides by -2. So I solve for y. All right. Give it a little bit more space. All right, solve for y, so this cancel out. So my y here, negative become positive. So my y here will be positive 1/2 of x, right? And then plus what? Minus, because 6 divided by -2 will be negative. So -3. All right. So I have a y equal to 1/2 of x minus 3. Okay, so I will have a y equal to okay, I'm trying to show you how to put this one in a vertical one. All right, so number 1, I have a y equal to 1 over 2 of x, okay, and then minus 3. All right, and then I graph them. Okay, so now this is the graph, right? So you can see this intercept here is 6 and 0. This is 0 and -3. So it will give you the same graph as we do that by hand. All right. So that's two ways to make a graph. You don't want to guess, okay? You will still have to solve them first before you put the answer in here. All right, so that is all the time we have for today. And as I mentioned earlier, this is recorded. So, for some of you, maybe some other people couldn't join online, they can still watch the recording. Any other questions? Any questions before we leave?
I had one question.
Yes.
I'm not sure if you know, do you know when we'll be back to campus? Or is this like an issue that will be for like the whole week?
Today definitely not the entire day today. So watch you alert or watch you Dallas College homepage. Okay, check the Dallas College homepage because it didn't in the alert. It didn't really, even I received the email from the president. It didn't say on specific time, so we do not know at this point. So probably early in the morning before you're trying to go to school, check the homepage or check your alert first. Just make sure it's open, okay?
Okay, thank you.
All right, you're welcome. Any other questions? Okay, so make sure you need to go ahead and complete the homework, okay? We finished 1.3 today, so make sure 1.1, 1.2, 1.3 homework need to complete this week. All right? Okay, stay safe. If you don't have any other questions, class will dismiss.